Here are the homework answers for section 3-7, starting on page 112, the oral exercises. Number 1, solve for y. We have an inequality with a greater than symbol. We're asked to get the letter y alone. We need to remove the x term. Subtract x from both sides. Y is greater than 6 minus x. I'm going to actually write negative x plus 6, but that is the same thing as having a 6 minus x. For number 5, solve for y. First, subtract the 2x term. We get 6y is less than negative 2x. Then divide by the coefficient of 6. Y is less than negative 2x over 6. This simplifies to y is less than negative 1/3 x. I've kept the arrow facing the same direction because I did not divide by a negative number. Number 13, does the given point belong to the solution set? Our point is 2, 2, and we're wondering, is that a solution to this open sentence? Let's substitute the numbers and see if we get a true statement. The first number is x, the second number is y. So put a 2 in for x, put a 2 in for y, and what we're wondering is, does the left side make a true statement? 2 minus 2 is 0. Is 0 less than or equal to 0? Yes, it is. Number 15, let's substitute 1 for y and 1 for x, and evaluate the left side. 2 minus 1 is 1. Is 1 greater than or equal to 2? No, it's not. Now we have the written exercises, and we're asked to make a lot of graphs. For number 1, we have a single inequality, y is greater than x. The graph of this inequality will have a boundary line. That line will be either shaded or dashed, and it will have shading on one side or the other of the boundary line. First, let's find the boundary line. This inequality is very similar to the equation y equals x. This is in slope-intercept form, where the number in front of x is 1, and the number on the end is a plus 0. That number is the slope, and that number on the end is the y-intercept. So to graph our boundary line, we're going to make believe that this inequality is the equation y equals x. It has a y-intercept of 0, so the first dot at 0, and the slope is 1. Rise 1, run 1. We're going to draw a line through these dots, but before we draw it, we need to decide if the boundary line is solid or dashed. Looking at this symbol, there is not an or equals to bar under it. So we want to have a dashed boundary line. Draw through these dots and draw with a dashed line. The next thing we're going to do is decide where the shading is. Because this is a greater than symbol, we're going to shade above the boundary line. So take your pencil and just shade in all of this space that is above the boundary line. We are covering over an infinite number of dots. Every one of those dots has an ordered pair for x and y. And all of these ordered pairs, if we were to substitute into this inequality, would create a true statement. Any ordered pairs that are actually on the boundary line, for example, the 1, 1, will not satisfy this statement if you plug them in there. 1 is not greater than 1. And that's why we had to use a dashed boundary line so that we weren't including those dots as part of our answer. Number 3, this has the same format as y equals 2x plus 0. So let's make believe that it's this equation. The y-intercept is 0, so the first dot there at the origin. The slope is 2, so you rise 2 and run 1. Now before we draw the line, let's decide if it's solid or dashed. This has the equal to bar, so this is a solid boundary line. Draw a solid line through those dots. Now we're going to decide whether to shade above or below the boundary. Look at this symbol. This is a less than symbol, so we're going to shade below the boundary line. Take your pencil and color in everything that is underneath that boundary line. We are shading over an infinite number of dots, and every one of the dots has an x coordinate and has a y coordinate. If you used those numbers for x and y and substituted into that statement, we would get a true statement. Next, number 5. This is like the equation y equals -2. This creates a horizontal line that crosses the y-axis at -2. Before we draw the line, let's look at this symbol to see if we want solid or dashed. It does not have an equal to, so we want to have a dashed boundary line crossing the y-axis at -2. Now we're going to decide whether to shade above or below the line. Look at the inequality symbol. This is the greater than symbol. Do you shade above or below? We'll shade above. To be greater than the boundary line means to be above the boundary line. Take your pencil and shade in all of the dots that are above that boundary line. Next, number 7. This inequality is like the equation x equals 0. Think what this looks like. This is a line, and it's a vertical line crossing the x-axis at 0. Before we draw it, let's decide if we want a solid or a dashed boundary line. We want to have a solid boundary line. So take your pencil, cross the x-axis at 0, and draw a vertical line. You're essentially just tracing over top of the y-axis line. Now we have to decide where to shade. Because this line's vertical, there's no above or below, but there is a left and right. So let's look at our inequality symbol. This is the less than symbol. Do you think you shade left of 0 or to the right of 0 when you have a less than? We're going to shade to the left. We're going to shade all of the dots that have x coordinates less than 0. So take your pencil and shade in all of this space. Next, number 9. Make believe that this is an equation. If this was an equation and we wanted to graph it, it would be helpful to have slope-intercept form. So let's change this into slope-intercept form. We're going to subtract 5x from both sides. We get y is greater than -5x. This is like the equation y equals -5x plus 0, where this number tells us the slope and this number tells us the y-intercept. So the y-intercept of 0 means at the origin. A slope of -5 means to go down 5 and run 1. 1, 2, 3, 4, 5, and run 1 to the right. Before we draw a line, we have to decide if it's solid or dashed. This is going to be dashed because there's no or equal to bar. So carefully draw a dashed line through those dots. Now we're going to decide whether to shade dots above or below this boundary line. Look at our arrow symbol. It's a greater than symbol. We want to shade above the boundary. So take your pencil and shade in everything that is above that diagonal line. Number 11. Again, it would help us if this was slope-intercept form. So let's add 4x to both sides to get the letter y alone. This is like the equation y equals 4x minus 2, where this number is the slope and this number on the end is the y-intercept. So it touches the y-axis at -2, and it has a slope of 4. That's a rise of 4, run of 1. 1, 2, 3, 4, run 1 to the right. We could do this again for more accuracy. 1, 2, 3, 4, and run 1 to the right. Before we draw the line, let's decide if it's solid or dashed. Which is it going to be when it has the equal to? It's solid. Now we're going to shade. Where do you shade when it's a less than? You want to be less than the boundary or under the boundary. So we're going to shade down here. We're shading over an infinite number of dots. Every one of these dots is a solution to this open sentence. For example, I hope you agree that one of the dots that we shaded over is right there at 3, 0. What we're saying is, if you used 3 for x and 0 for y, we would get a true statement. Do you believe it? 4 times 3 is 12, take away 2 is 10. It's true that 0 is less than or equal to 10? Yeah, that's true. Number 13. Let's put this in slope-intercept form because that helps us make the boundary and know where to shade it. First, let's add 2x to both sides. We get 5y is greater than or equal to 2x plus 6. Now divide by 5 to get y alone. We get 2 over 5x plus 6 over 5. The 6 over 5 is the same thing as the mixed number 1 and 1/5. By doing the y-intercept as a mixed number, it'll help us locate it on the y-axis. The y-intercept is 1 and 1/5, so a little bit above the 1. The slope is 2 over 5, rise 2, run 5. When I rise 1 unit, I'm a little above the 2. When I rise another unit, I'm a little above the 3. Now I'm going to run 5 units to the right. 1, 2, 3, 4, and 5. Notice I'm a little bit above the line for the 3. Before we draw, we need to know if it's solid or dashed. It's got the equal to line, so it's solid. Where do you shade when it's a greater than symbol? You shade above. Next, number 15. Let's put this one into slope-intercept form. First, add the 3x. We get 4y plus 12 is greater than or equal to 3x. Now subtract 12. We get 4y is greater than or equal to 3x minus 12. Then divide by 4. We get y is greater than or equal to 3 over 4x minus 12 divided by 4, but that's just a 3. So the y-intercept is -3. The slope is 3/4, or a rise 3, run 4. 1, 2, 3, 1, 2, 3, 4. Should the boundary be solid or dashed? It's a solid. Where do you shade, above or below? You shade above. Next, number 17. Let's put this in slope-intercept form. It almost has the letter y alone. We just need to divide by -1. When you divide by a negative, you switch the arrow. 2x divided by -1 is -2x. -4 divided by -1 is +4. The y-intercept is at +4. The slope is -2. As a fraction, that's -2 over 1. That does our rise and our run. So we're going to go down 2 and run 1 to the right. Down 2 and run 1. Down 2 and run 1. I can do this repeatedly. Is it a solid or a dashed line? There's no or equal to symbol. So it's a dashed line. Is the shading above or below? Well, this is a greater than symbol, so you shade above. You can tell that if you forgot to switch the arrow when dividing by a negative, that you would end up shading the wrong side of the line, and that would be an incorrect answer. Number 19. Let's solve this one for x by dividing both sides by -1. We get x is greater than 0. This is a special case. It's a vertical line, and it crosses the x-axis at 0. So we're going to trace the y-axis, but we need to trace it with a dashed line. So to make it show up, I'm drawing on the y-axis, but kind of just a tiny bit to the side, just so it visually shows up. Where's the shading go? Where are the numbers where x is greater than 0? Are they over here to the right of the line or to the left of the line? They're to the right of the line, so you shade in all of this space. Number 21 is a system. This time there are 2 open sentences. When we graph them, they're each going to create a boundary line, and they will each have shading. The overall solution of the system will be the region of space where the shading overlaps, because those dots solve the first one and solve the second one. Let's graph the first inequality, the one in black. This is like the equation y equals x plus 0, where the slope is 1 and the y-intercept is 0. So that y-intercept dot is at 0 and a slope of 1 means rise 1, run 1. Is it a solid or a dashed boundary? It has the equals to on the arrow, so it's solid. So you draw a line through those dots. Where do you shade? This has a less than arrow, so we want to shade under that line. Now I'm going to switch to blue and graph the second inequality. This one is like the equation y equals negative x, or y equals negative 1x plus 0. It touches the y-axis at 0, but its slope is negative 1. Down 1, run 1. Is it solid or dashed? It does have the equal to line on it, so it's a solid line. Where's the shading compared to that blue boundary? It has a greater than. You shade above. When we graph the solution to a system, we want to know where the points are that solve both of them. Do you see any overlapping of the black and blue shaded in region? That's the actual answer to the system. So I'm going to go over with my pencil and very carefully graph in the actual answer to the system. I'm going over the overlapping region with the pencil so it shows up really good. That way I know that it's really this green area that's the answer, not this black down here or this blue up there. Next, number 23. Let's use the same technique. We're going to graph the boundary lines and do the shading for both, and then we're going to look to see where the shading overlaps, and then darken that in extra good. So this first inequality is like the equation y equals x, or y equals 1x plus 0. It touches the y-axis at 0 with a slope of 1, so you rise 1, run 1. Is it solid or dashed? It does have the equals bar, so it's solid. This is a greater than symbol, so you shade above. All of the answers for the first statement are above the boundary. Let's see where the answers to the second statement are. This is like the equation x equals 0, which is a special case. It's a vertical line crossing the 0. So you're basically tracing the y-axis. Is it solid or dashed? It's a solid. So I'm tracing over the y-axis. Now I want to shade. Do you shade left or right when this is a less than? You shade to the left. Now, where are the answers to the first one and to the second one? That is, where's the overlapping space? Take your pencil and darken that answer in really good. The shaded in region in green ink is the solution to this system. Any of the dots up in this area that was shaded in black only are solutions only to the first one. Any of the dots down in this area where there's only blue shading are solutions to only the second one. But anything where the shading overlapped are solutions to both of them. Next, number 25. Let's graph the first one. This is like the equation y equals 1x plus 1. A y-intercept of 1 and a slope of 1. So rise 1, run 1. This is a solid line. This has a greater than symbol, so you shade above. Now the blue one. This is like the equation y equals 1x plus 2. So a y-intercept at 2 and a slope of 1. That is, rise 1, run 1. This has the equal line, so it's a solid line. I notice that the black boundary line and the blue boundary line are parallel. Where's the shading go for the blue boundary? It has a less than. So we're going to shade under the blue. Where is the overlapped shading? It's above the black line, but under the blue line, or in between the lines. We're shading over an infinite number of dots right now, and all of those dots solve these inequalities if you plugged in the numbers for x and y. Next, number 27. This first inequality is like the equation y equals 2x minus 3. So a y-intercept of -3 and a slope of 2. You rise 2, run 1, rise 2, run 1, rise 2, run 1. Solid or dashed? It's solid. This is a greater than symbol, so you want to be above this boundary. Now the other inequality statement. This is like the equation y equals -x plus 2. Notice how I manipulated the x term and the constant term to get slope-intercept form. The y-intercept is at 2, and the slope is -1. So down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1, and so on. Solid or dashed? This one's dashed. This has a less than symbol, so we want to find all the dots whose y coordinates are less than the boundary. So under the blue line. Now let's figure out where the answer to the system is. We know where the answers for the first one are. We know where the answers for the second one are. What about for the system? Where are the answers that solve both of them? Take the pencil and go over the overlapped region really well. Next, number 29. Let's take the time to transform these, because we know that slope-intercept form is really helpful when graphing. Let's subtract x from both sides. We get y is less than -x minus 6. So the y-intercept is -6, and the slope is -1. That is down 1 over 1. By the way, we could also go up 1, left 1, up 1, left 1, up 1, left 1. That also does a slope of -1. This is a dashed line. We have a less than symbol, so the answers are underneath that dashed line. Now the other one. Let's take the time to transform this one by adding 2x to both sides. We get y is greater than 2x. So the y-intercept is a 0. And the slope is a 2. Rise 2, run 1. Rise 2, run 1. Rise 2, run 1. By the way, you could also go down 2 and left, and you would get dots that line up in a straight line. This does not have the equal to on it, so it's a dashed line. We have a greater than symbol, so the answers are above the boundary. Now take the pencil and darken in the overlapped region really well. We're coloring in under the black line and above the blue line. Next, number 31. I notice that these are not in slope-intercept form. Let's take the time to put these in slope-intercept form. First, subtract 3x from both sides. We get -2y is less than or equal to -3x plus 6. Now divide by -2. We get y is greater than or equal, because you switch the arrow, 3 over 2x minus 3. The y-intercept is -3, and the slope is up 3 over 2. This is a solid line. It's now a greater than symbol, so we shade above. Let's transform the other one by subtracting 2x from both sides. We get 3y is greater than or equal to negative 2x plus 6. Now let's divide by 3. Y is greater than or equal to negative 2 over 3x plus 2. So the y-intercept is at 2, and the slope is negative 2/3. Down 2, run 3. Down 2, run 3. This is a solid line. We have a greater than symbol, so we want to be above the blue line. Now find where the shading overlaps. Above the black line and above the blue line. Number 33. We're told that x is in between 0 and 2. There's no y in this. This is like having equations that have only an x and no y. These are vertical lines. So one of our boundaries is 0. Let's draw a vertical line crossing the x-axis at 0. It is a solid line. The reason it's solid is it has that or equal to. Now let's draw a vertical line crossing the x-axis at 2. And it is a solid line. Now let's figure out where the shading is. What is this telling us about all of the dots' x-coordinates compared to 0 and 2? It's telling us x is in between 0 and 2. We want to color all the dots who have an x value between 0 and 2. That's anything in between the boundary lines. For example, this dot is at 1, negative 4. It has an x value between 0 and 2. Its x value is 1. Now number 35. Let's solve for y in the middle of this expression by dividing by negative 1. We get negative x plus 2 is greater than y, which is greater than negative x. I switched the arrows because I divided by negative 1. It might be easier to graph these boundaries if we separate out this combined statement. When you focus on this portion of it, that is the same thing as having negative x plus 2 is greater than y. And when you focus on this portion, that is the same thing as having y is greater than negative x. This one here doesn't look like what we're used to, where the letter y is on the left side. So let's rewrite this as y is less than negative x plus 2. Notice the arrow is pointing at the y and the arrow is still pointing at the y. That maintains the correct kind of symbol. Now we can graph these. The y-intercept of this is at positive 2. The slope in front of x is a negative 1. So down 1 over 1, down 1 over 1, down 1 over 1. This is a dashed line. We have y is less than our dashed line, so we shade under. I'm going to switch colors and graph the other one. Y is greater than negative x. This is like y is equal to negative x plus 0, where the y-intercept is 0 and the slope is negative 1. So y-intercept 0, a slope of negative 1 is down 1 over 1, down 1 over 1, down 1 over 1. This does not have a bar on it, so it's a dashed line. I notice that this boundary line is parallel to the other boundary line. Where's the shading go when it's a greater than symbol? We shade above. Now let's think about where the answer to the combined inequality is located. Where did the shading overlap? Where is it under the black boundary line and above the blue one? That would be in between. So as I shade here in green, I'm actually shading over an infinite number of dots, and every one of those dots has an ordered pair that would work if you plugged in the numbers for x and y.